This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe think tank.
The Fringe think tank it is then. Now let's give them back their destiny and open it up to the world.
Hello, everyone. My name is Nathan, otherwise known as Old Man Builds. We have Joe here today, and we have the Benny Factor.
How you doing, everybody?
What's going on, guys?
Hey, everybody.
We're going to be talking some Hutchison today. So it's going to be a fun walkthrough. What do we know? What do we don't know? What can we learn from all the stuff that he's done? Because there's a lot of experiments that he's done out there. So it's kind of going to be an interesting conversation. How's everything going, guys?
Yeah, pretty good. Yeah, excited to get into this one. Hutchison is definitely this generation's kind of OG at this point. You know, he's been trying to rediscover and resurrect a lot of these technologies since late 1970s, early 80s, and has done a pretty phenomenal job of documenting it along the way. And he's still kind of around and trying to replicate now what he used to do. Obviously, sometimes things are easier said than done, but I think that as far as this generation of electrical engineering is concerned and what the things that we talk about, he was definitely a pioneer at the forefront.
He's definitely what inspired me to get into some of this stuff. You know, looking up some of his experiments and what he did, it was just impressive. I do have like a quick 3-minute video I threw together for you guys at some point if you want to watch it, just on his background story.
Yeah, you checked everything with the YouTube bin, and we're clear to play it?
Yeah, it's using my own music. So it's just basically screenshots and the AI voice.
Yeah, throw it up. Let's give it a roll.
All right.
That's cool. Give everybody some perspective on what we're doing.
Yeah, because I had the episode 3 for Divine Science outlined already with some of his information, so I just figured let's give you a quick preview of some of that because I already had it up there.
Cool.
Yeah, very cool. Roll it, man. Let's see what you got.
There it is. Is it on browser having trouble sharing your video? Oh, it's an email file. Okay, I'm gonna convert the file, so that'll take me like maybe 10 minutes. So we'll get back to that.
We'll talk to it then about it then.
It won't take long.
All right.
Cool.
So recently, Hutchison just went live, and he was with his wife, and they were talking about some of the stuff they were doing, and with the mathematician guy, I think it was. That's the channel I watched it on. And also Charlie C was on there with them, and they were talking about the products needed to replicate his experiment. And we're all thinking the anti-gravity experiment. I don't think they were replicating his crystal cell. But it was interesting in the amount of voltages they were looking at. So most people probably wouldn't realize this, but an off-the-shelf Tesla coil is not going to get you there. He's talking in excess of like 400 volts going into some of this equipment. That's got to be at least 40 amps, 50 amps. God knows it's probably more than that. But the normal Tesla coil we use, or I use in my garage, is not anything close to as powerful enough to put off the, amount of energy he's doing there. So it kind of tells you what type of energy he's using to create this experiment.
Yeah,
Yeah,
that's for sure. It's definitely hot side.
Yeah. Yeah, he didn't you I think someone said like he would have to wait sometimes hours or days for the field to build up enough.
Yeah, he would. It wouldn't lift right away.
Hmm.
So, for those of you who do not know, there's two sides of gravity that you should be aware of. There's a hot side and a cold side. Some people call them, gravity A and gravity B, gravity 1, gravity 2, however you want to describe it. It's there. What's going on, Gerald?
Hey, Gerald.
Hey, Gerald.
That's a nice surprise.
Yeah, I sent you a link if you want to hop on, Gerald. So, yeah, he's definitely working with the hot side of gravity. So let me just kind of set up the experiment so everybody can kind of understand what we're talking about here. He's got a Tesla coil in there. He's got static generators in there. And he's also got plasma in there in a bottle. And then he has his room, which is completely filled with electronic equipment and heavy amounts of metal. So depending on where he did his experiments, whether it was in the apartment or the metal shipping container, he may have got various different results. So all of those things are an absolute factor in this. So anyway, the reason I bring up the Tesla coil, if you know anything about Tesla coils when you turn them on, if you find that resonance point, and it's not when you find an off point or one that's good enough, exact resonance point, everything in your room gets hot. Now, it's not physically hot. It's cold. But when you touch your finger on it, it'll completely burn your finger. So just understand that there's energy being imparted on every piece of metal surface in that room. So when you look at his metal that's hanging around him in his apartment where you normally see everything, all of that has it all over it. So touching anything in that room would just be out of the question, especially with something, astronomical like the Tesla coil he has.
Yeah, and it's interesting because, as we said before the cast, in his some of his days of earlier experimentation, he wasn't really doing everything out of his apartment like it kind of came to be. For a long time, he was doing a lot of his work out of a trailer, a steel shipping container. So just imagine, the field that would be inside that small container like that, with all that equipment in there too. It's even magnitudes greater than running it in an apartment like that.
Well, yeah, you think if you're creating cavitation somewhere and you have high static electricity generators, it's not going out of that room. So you're filling that entire room with static electricity. You're basically inside of a plasmoid at that point. You created a external field with the walls, especially in the shipping container, and now you're holding it in, right? Now, if you're talking about time it takes to do stuff, it probably took half the time sitting in the shipping containers than it did in his apartment because it would leak everywhere.
And apparently, Gerald has a direct connection to where that steel shipping container was. So, of course, it always turns into a small world on the internet when you're in the right crowd, right?
Well, Gerald's in Canada, so
right. Yeah, I know that. But I think Hutchinson's not even in Canada anymore. I think he's in Washington State now.
Yeah, probably. I'm just saying when he did his experiments, he was out in Canada.
Yeah, that's for sure. But what I think is interesting about, and Gerald said before too, it's you don't forget how to do these things. You can't not replicate it. He kind of said he's lying. He's scared.
Yeah, I would be too.
And honestly, given the results and everything that he had out of his experimentation, who can blame the friggin' guy? And there's a lot of pressure on him through communities like this to go and show the work again and get that next generation going. The guy isn't getting any younger, right? So at the end of the day, I could understand why he's trying to humor everybody, but at the same time, right, it seems a little improbable to not be able to replicate something that you had for almost a decade and a half replicated countless times to countless people.
Oh, he replicated it to the DOD.
Yeah.
I mean, you can't replicate that to anybody else after that. Not if things are in anti-gravity. He's probably like not allowed to at all, and he just humors people. I think that's why when he describes all the equipment, he has like 5 times the amount of equipment than you would need for the experiment.
Oh,
but he puts it in there anyway just to kind of throw people off. You know what I mean?
Right. Yeah. You don't
his
know what he's
apartment was
running.
filled with it.
What's up, Ben?
I said his apartment was filled with it. Remember, his apartment, you could barely walk through. There was so much equipment.
Yeah. Well, but that's the thing. Sure. He doesn't need all of it to do the experiment. He simply tells everybody he does. You see, there's only a couple factors that's really important in that thing. Once you learn it, you have it. But he could do it for like a quarter of that equipment, and he knows it.
See, what's interesting about him just as a character, well, I mean, so many things, I suppose, as a character, but is that he has so much material out there as far as the experimentation, the documentation of it goes and everything like that. And none of it is talking theory as to what's going on. And before the age that we're in now, an age of greater understanding and just changing times with the physics and everything like that, getting your head around what type of wizardry was going on back in the 80s and early 90s would have been nearly impossible for the average person generally. Like, you could never look at and speculate what would have been going on for the most part, I'd have to say, at that time. But now I think that we could look at and definitely have a really good idea of what's going on, but that's with the changing times. But he never really talked about what was going on in any of the experiments ever.
No. By the way, just so you guys know, he found the cold side of electricity, or negative side, however you want to interpret that word. He had both, and they use it right in front of you. And with the stuff that they do, when they're growing their plants, they're using the cold side. When they're doing anti-gravity, they're working on the hot side. And it's just funny because I don't think many people realize that at all. His crystal cell was based on the cold side of energy because, as we talked about on the show so many times, it interacts with the water and the actual crystals in it in order to produce the energy at a higher rate. He's definitely working on the hot side of energy when he created his anti-gravity, but I think he could have well done it on his cold side as well. When he cleaned the water, he did it on the cold side.
Right.
So,
but yet the results are somewhat similar in terms of what you can get out of it. It's all just about what frequencies you're putting in to be able to attain it, and that sort of thing. I mean, if you'd like, I mean, maybe we could speculate about how he was, twisting metal and breaking and dematerializing metal, because I mean, I think that that's something that we've pretty much discussed at length. Whether it's realized or not, we don't always point out his examples, but anytime that you're putting that type of charge onto metal at a certain frequency and resonance, and you start a cavitation effect that starts breaking molecular bonds, creating gaps in the molecular structure, and then that charge accumulates in those gaps, and then the expansion of that charge in those gaps leads to separation and mutation and dematerialization of that crystal structure of the metal. And what's interesting is how when they ran the spectrograms on it to see what the composition was before and after the test, what they found is that there wasn't all that much necessarily transmutation in those cases. However, there was a much higher concentration of the already present impurities at the site of reaction. So basically, what it was doing was it was precipitating all of the impurities into this reaction zone. And that's a phenomena that we see in nature all the time when it comes to mineral and crystal formation in itself.
So this right here, I put this up because you're talking about the cavitation.
Yeah.
This is actually Hutchison's metal right here. Tim Ventura put this up, by the way. But you can see all the little pit marks on it.
Yeah,
like it just
bubbles.
like it got struck with high voltage everywhere or something like that. Is exactly what that looks like.
Yeah. Now show those props that I sent you, just so people have a comparison. So I don't know if you could zoom in on that.
I can't.
No,
it's the same phenomenon. It's the same type of cavitation.
So right. So as soon as I saw that, I was like, in the video that that first screenshot came from, they were referencing it as erosion, and he was alluding to the fact that, well, we don't know if the erosion happened at the time, or I saw these 20 years later. Maybe it was then. I saw them, and I was immediately like, I've seen that before on propellers that are out of tune and running like crap.
Yeah.
Because anytime a propeller is creating high degrees of cavitation, you have cavitation erosion on the props. In one of the photos, and it's too small on my screen to tell if that's the one or if it's the other one I sent Nathan, but you could actually see the strands of the metal, how they're actually forming in the same type of structure that was occurring when the metal bars were splitting apart. It was like separating them layer by layer, and leading to channels and stuff. And on one of the prop pics, I know that was present too, which I found really interesting. But
that's on the top picture,
right? So that last the one of the metal that he did, that's absolutely cavitation pitting.
I'll just
looked exactly the same in the inside of the thunderstorm generator bit that they cut apart.
Give me a second. I'm gonna pull that picture real quick if I can. And I'll just zoom it in so everybody can see it. There you go. You see the strands right there.
Yeah, that's the stranding that I was talking about. Yeah.
You can see all the pits in there and everything. Yeah, it's the same thing. So he's definitely creating a plasmoid in there.
Yeah.
When the longitudinal and transverse waves hit it and they connect, it's no different than two laser beams coming together and making a plasmoid. You're doing the same thing. You created it in the cavitation. So any pits or holes inside and any impurity in there that creates that, because remember, when this energy hits it, it's going to start to burn that material. It's going to have a natural barrier around it. And then you're going to get static buildup that just bounces everywhere. And if that frequency is at the right frequency, you're going to get a plasmoid right in there. So we see that in other experiments as well. When you start to do them, you'll notice that that's taking place in there.
Yeah. But all that takes for that whole dematerialization process to undergo, once enough saturation charge has been built up on that, is it just needs to find that one spot that it's going to break that molecular bond. Once that bond is broken, it's a somewhat cascading effect at that point. Once you break one bond, there's an instability. The charge is now reaching more places, and all of a sudden it's breaking apart.
Spiderwebbing glass, almost.
Yeah, pretty much. And yeah, I think we all saw the Rossi interview. I thought it was fantastic.
Absolutely.
Yeah.
Yeah, he covered a lot of the stuff that we cover. Go ahead, Ben.
Oh, yeah.
Oh, no, I was just agreeing. That was a good interview. I do have that video up whenever you want to transition into that video. It's only 3 minutes, but it serves as like a good background story, I guess.
Well, let's give it a shot.
John Hutchison's story. It is late in the evening in Vancouver when young John Hutchison hears something remarkable. An enthusiastic tinkerer of electronics, John has been listening to the static in between station frequencies on the radio when he stumbles upon a sound. A frequency of 30 cycles per second, John hears what appears to him as giant coils attached to massive hydroelectric motors. Like many innovators before him, John was able to visualize these components in his head, reconstructing them like watching a movie play out on a silver screen. There have been many visionaries that claim to have this same ability, the ability to completely visualize a complex concept inferred from the tiniest bit of instinct. We have already discussed how Tesla, Buddha, and Einstein share possible connections in my parallel worlds theory. Fast forward a bit to when John was older. As an adult, he continued to experiment with high-voltage equipment and magnetic fields. He began to notice strange phenomena that defied conventional understanding. Metals seemed to bend or even levitate, and electrical components would behave in unexpected ways. These unexplainable results set the stage for the Hutchison effect, a series of experiments that still spark debate and intrigue. Although his work was dismissed by many mainstream scientists, it planted seeds of curiosity in those willing to challenge the boundaries of established physics. John's hands-on approach, blending various fields of electromagnetism and energy, laid the groundwork for future researchers to explore unconventional concepts in energy, materials science, and gravity. In many ways, his experiments have continued to inspire modern scientists and inventors who dare to venture beyond the status quo. Though John Hutchison's claims have never been fully verified under controlled scientific conditions, his influence is undeniable. His experiments challenge the rigid boundaries of traditional science and spark discussions that persist today. Concepts like anti-gravity, free energy, and unconventional material properties, once thought impossible, continue to inspire cutting-edge research in fringe science. Hutchison's work lives on as a reminder that the limits of what we know are always shifting, and that scientific progress often comes from those who dare to think differently. In the years since, his influence can be seen in the work of modern inventors and theorists who continue to explore the potential for harnessing energy in ways that once seemed unimaginable. Hutchison's legacy is one of curiosity, innovation, and the ongoing quest to understand the mysteries of the universe.
News of John's incredible discoveries spread like wildfire through the scientific community, and people from all walks of life attended John's humble home to see the effect in person. He'd opened his laboratory to fellow researchers and curious minds, inviting them to witness the effect firsthand. One particular witness to the event would become close friends with John, George Hathaway.
Something quick to give you some background information on John.
Yeah, very good, Ben. Thank you.
That was awesome.
Yeah, man.
Yeah, no problem.
Well, for those who didn't know before the video, now you do.
Yeah. Yeah, I didn't want to make it too long either. It gets boring after a while.
Yeah. Yeah,
You know,
I do particularly love the dancing Red Bull can. That one was pretty good.
Yeah, that was my favorite clip.
So the soda bottle had no lid. The what was it? Bleach bottle, is that the one he used? Had a lid. So he had to vacuum it. It was in some sort of vacuum. It took the whole bottle and crushed it. And then the other bottle that had no problem getting anything out of it stayed whole. It's an interesting note to kind of check off there that his room became a vacuum. So he didn't have to put a chamber around it to do this. He did it in the open air. So when you start talking about your experiments, I know a lot of people say, put it in the vacuum, put it in the vacuum. You should be able to create the vacuum on your own, depending on the environmental condition that you build. That's the point.
Yeah, that's interesting. That's an observation I didn't make. Like, that's something that I didn't put together. That's interesting.
Well, cavitation's interesting because it's like an as above, so below thing, like everything else, right? So you can have it at these small scales, but you got to remember, like when you're building fields out and out and out, and you're actually reaching saturation of an entire room, for instance, there's cavitation going on the larger scale too, and cavitation is no different than the action of the burning of the sun, whatever, you get what I'm saying, where it's a constant state of like collapse and expansion.
Yeah, that makes sense.
It's a collapse and expansion differential that's occurring like this, that's creating pressure differentials on a capped bottle that would create, an ever pressing force on it, especially when you're toward the middle of those fields.
That makes a lot of sense when you explain it like that. It does.
Yeah.
It's just interesting at the fact that you have to look at every little part of why he's doing something. Like before Gerald came along, and he'll tell you, we all didn't take in consideration the room. And now that he told us, I do it all the time. So it's just interesting because then you start looking around and go, okay, it's all a bunch of metal equipment in there. He's got a pressured environment. It's not going anywhere. Then he's running static electricity through the roof, which means that room must have been uncomfortable. Like your hair would be standing up everywhere. Every surface that you touch because the Tesla coil would be hot to the touch. I mean, that would be one of the most uncomfortable things in the world to be inside.
Yeah, but you'd have to worry about frying your phone or whatever and all that stuff, right?
Oh, they'd all be dead. I'm sure he killed phones from the neighbors. Well, maybe not in the 80s, but he would now.
Somebody walking by, I'm like, what the hell?
Yeah.
Hey, I always say, like, well, I couldn't imagine the effect on the electrical system in your house with all the Romex running through your walls. Like, I mean, it's affecting all that stuff too.
Yeah.
Well, his neighbors used to say that their stuff would come off the ground too, or fly in the air.
That would freak me out.
Right. He's putting all that charge through the grid, and it's going through the walls of the neighbor's house.
Yeah, that's crazy. That's awesome.
Well, think about what that means, though. So that means that the static electricity left the room, and so did his Tesla coil field. That Tesla coil field, like I said, it builds out like a gas and holds that static field in. So that sucker must have been huge. Like, I mean, we're talking, he could have had the whole apartment complex. He could have disappeared the building if he wanted to, man. So, I mean, think about it that way. How much energy is putting in, how far does the field go? I mean, all that stuff matters. It's like, you think you got your little Tesla coil, you have 5 feet and you're happy. No. He's pushing 30 feet easy on that Tesla coil. There's not a whole lot of spark discharge that's wasted. You see the little plasma there. That right there could have just been his Tesla coil plasmaing out. You know what I mean? But he's holding the charge in. It could have just been so that it doesn't go into the room and suck out all the needed energy in there. You see, it could have very well been that instead of somebody just going on and saying, well, let me make a high voltage generator, put it into there and start this plasma reaction. Could have just been his Tesla coil discharging. And he didn't want that to come in contact with anything else that was going on in the room because it would disrupt the static charge and energy in the room.
Right. So for people that don't realize this is, and this is something that I probably saw physically for the first time today. Nathan had sent me a video with some bismuth above the Tesla coil, right? But when you have a saturation in your room and you have something that's capable of arcing over and discharging, it doesn't necessarily arc over from the source of emission like you think it does. The potential coming from the source in a high saturation zone could hit the other way too. And that is taking it out of the room, because anytime you're discharging it, it's a reduction, right?
Mm-hmm.
So you got to understand that sometimes you see like a Tesla coil, for instance, sparking out, right? Not all those sparks are coming out of the Tesla coil. I think that's a pretty big misconception at this point. Some of them are coming opposite way too. And that's just the way it works, especially when the saturation levels are high. If you never let the saturation levels get high, then chances of that being the case are less likely. But the arcs still need to have a point that they're going to strike. It's not random, right? So that it's pulling energy that's ambient energy it to a point of concentration, to the point where it could hit and make that connection, and it could be like a middle type of thing at that point, no different than a lightning bolt. Okay, but there are situations in high density saturation where it'll just straight shoot the opposite way, right out of thin air to the coil.
Yeah. Sorry, I'm reading the comments. By the way, the frequency was so much more important than we realized.
Mm.
The saturation point's easy. So you get the energy in the room, you create the bubble, you got saturation. That part's not the problem. If you're messing with the frequency all the time and you're channeling it, so you're just going back and forth and seeing which ones are the high spots and low spots on your oscilloscope, and you're doing it manually, it could take forever to hit the right frequency for every little part of it. So it just could be the frequency that particular bubble likes to move in. And I don't think because it's just lifting up, he's not directing charge. So you can't use the Biffle-Brown effect on it because you cannot distinguish where the charge is. So he's going to have to just wait until that whole thing saturates and hits the right frequency, and then it can move.
Yeah, so, I mean, this is not experimentally coming from my mouth, obviously, but just theoretically. If you're in a constant state of searching and you're emitting all sorts of different wavelengths into your atmosphere, when you start changing it, then you're going to have all sorts of different sorts of interference that needs to be able to be overcome before you could start saturating at another frequency. So all things are relevant at that point. The waves just don't go away.
So real quick, just Jarvis asked a question. What frequencies, how often did he change them? If you look at his video on the pond, and it could be a lake. Anyway, he was cycling through pretty fast. So there probably was several, but that could have just been a front for him showing that he channels through them. You know what I mean? Like a fake part. I would imagine he scrolled through it ahead of time and just looked for a bump in something and then scrolled back to it. That's what I think he did.
I also have that Monk's chanting audio file that I really want to try to find. I haven't been able to find it anywhere. So if anybody has access to that, let me know.
And what was that file about?
It was like when he was doing the water, we're not allowed to talk about it, but he was like doing stuff with the water. He was putting frequency into the water, and he was also putting like this loud monk chanting audio clip through a loudspeaker. So it was, but I haven't been able to find that audio clip anywhere.
Adding low frequency into the mix.
Yeah, I think maybe that's what he was doing. I can't remember exactly what it sounded like, but yeah, something like that.
Well, just so everybody's aware, the more windings you have in your Tesla coil, the lower the frequency. Excuse me, the higher the frequency. Hold on. Let me see. I think I screwed that up. In a Tesla coil, the more windings that you have is the lower the frequency. The least amount of windings that you have is the higher the frequency. So if he built that thing for extremely low hertz frequency, which you can do, that would change a lot of things. Because then you get into Schumann resonance, you get into the 20 hertz vibration that we all experience. You get into the metal frequencies in there at 8 hertz. So yeah, you could really change some stuff in this world if you got into the low hertz. Most people use the Tesla coil to get into kilohertz. Well, I don't think that's what he's doing. So if I were to build like a 6 inch wide pole and wind it up, say about 5 feet, I might get that sucker right down, I don't know, about 100 hertz, maybe 200 hertz, somewhere in there. But if I go bigger, then I can drop it even more. And then I can stick rods and stuff down it to lower it even more. So, Yeah, depending on exactly how he built that thing, he could have been in the hertz the whole time. And we will never see it in the Tesla coils because we don't build them like that. And the fact that they show up at your house with, nice vans to stop you is probably one of the reasons too.
Do you think that cymactics would show anything on a very, very, very low frequency?
Yes.
Yeah. I was wondering about that.
Oh, absolutely. I mean, it's omnipresent. In fact, like on the surface of the earth. If you look at sand and stuff like that, yeah, wind will help and everything like that, like on a beach or the desert, right? There'll be some different wind effects and whatnot. But if you take a bigger look up, you see it's a replicating pattern.
Yeah.
And that's because of, the Earth cymatics.
Oh, that's interesting. I never thought about it that way.
Yeah, you zoom in and it's the same ripples and mounds, ripples and mounds, ripples and mounds. And, when you zoom out, it looks like ripples and mounds. So it's present and observable just naturally. You don't need to run an experiment for that, but you certainly can. There's a lot that you could figure out with just having like a membrane hooked up to a resonance chamber. Do it.
Yeah.
It's fun.
Yeah, cymactics is always fun. I've been wanting to do another experiment with it, but I don't have the proper setup. But I'm interested in to see if you have any effects with your Tesla coils.
Effects on what?
Cymactics.
Maybe. I haven't tried it yet. So to be what I don't know why I haven't tried it yet. I just haven't.
There's so much stuff that we got to do. There's so much shit on the list. Well, I haven't been able to get to anything.
Yeah, but really what cymatics is good for is seeing what types of standing waveforms a certain frequency is creating. But what's interesting about it is that like everything else, environmental variables play a massive role in even the outcome that you get. So it tends to be inconsistent. Now, what I mean by that is, the type of membrane, the pressure of the resonance chamber, the size and shape of your cymatic plate. All of these factors will change what the standing waveform is of any given frequency. And I think that what it stands to do is actually show changes of the waveform. So if you were monitoring a cymatic plate and looking for a change in a waveform that you were putting through it, it would show it to you, right? And you wouldn't necessarily have to hear it or be able to hear it, right? It would just be able to show you what that change is.
So I don't want to go deep into the this aspect, but I'm going to say this. You'd always see in ancient societies what looked like a bell sitting on top of a chamber, and that bell resonated at a certain frequency. Anytime that the energy was in that chamber, then the bell would resonate, and that the energy's in there and available to be used. So just so we understand this, people knew about this a long, long time ago. And the part that I don't want to speculate on is what they were using the chamber for. But
right.
Yeah, we're not allowed to, or else I'd just flat out tell you. But there's certain frequencies that work better around people than some other ones. So
yeah, like 528.
Or even the low ones like 20 hertz.
20 hertz, yeah.
So it's kind of strange, like when they go out into space and stuff, there's a lot of things that go wrong with, the space people, the astronauts that go out there. Like they come back and all their legs are swelling and everything. People. Yeah, the space people. The little blue people. They have to get, water pills and stuff to clean them out because they're like bodies inflamed. And they're not having the same frequencies, that you would experience in the Earth's atmosphere. So they have to readjust to life when they get back down here. The space people, that is.
Space people.
Oh, Yeah, it's kind of funny. So if you just went over there, somebody's talking about the horns right here. Like Ricola, that commercial, the big horn.
Yeah, right. Yodeling and stuff, and like the big Swiss Alp horn.
So here's a whole thing for you here. Take all those things that you see in those pictures, find the natural frequency for every one of them, and then put it on a crossover map of a geometry coil, and just find the spots in that geometry coil that would match up, and they just have to match up in a scale. So they don't have to be the first frequency of A. They could be the third or fourth or fifth, and you're going to find something very, very interesting. That it was all in there. It's the same thing as your pattern when it comes to your crystal. The reason it makes the formation it does is the frequency you put in there, or frequencies, I should say. Every single one of them forms in a certain way, and they continue to form the same shape based on what you put in there. It's an overall resonance of what the shape you're finding. So,
yeah, now there are ways to hack those geometric waveforms that occur. Also, just by running different beat frequencies through a multi-channel. So, there's always more than one way to skin a cat. I like to say, it's
yeah, there's ways of doing things a little easier, I guess, but there's some ways that are powerful and some ways that are not.
definitely.
So, I mean, how do I say this in a way YouTube will accept it? A direct frequency is always better than an indirect one. So you don't want the like the skin effect to get in your way. So, and I can't tell you how it's done. I could just tell you that there's a way, but one is like 90% efficient. The other one is like 40% efficient. And those kind of things, I mean, we have to talk off YouTube to understand, but there is a direct way to do those.
Is John
and for the members and stuff, I'm sorry to cut you off, Ben, but just real quick, for the members and stuff, Nathan and I were discussing different ways that we might actually be able to have those particular discussions for the members of the channel. But I think that we're still working out the logistics of that right now, because we don't know if that's a discussion that we could have on a members only stream or not. So once we overcome that hurdle, I think that that episode is overdue.
Yeah, what it is we didn't want to go off platform to have it, but we don't want it out there for everybody to watch and get in trouble with YouTube. So I wouldn't mind putting it on a stream that I removed from my YouTube, but I don't want them coming back and nailing me for it later. So it may be something we have to redirect people. And I try to avoid that as much as possible because I want as many people in the discussion as we possibly can. So we'll look into it and see if YouTube gets back to me and says, hey, yes or no, and then we'll decide from there. But it definitely has to be talked about because it's a big part of the picture of what's going on here. And it takes the understanding of one thing and links them all back around together to the original point, if you get what I'm saying. It's the last piece of the puzzle that everybody needs to find. And once you find it, the whole world changes for you. Your understanding of why each thing is working the way they do now is understandable. It's like taking physics and putting back the cold side of energy into it to understand it, or room temperature and below to understand something. Then you start to really understand what's going on. So anyway, that was that one.
Yeah,
I want to definitely go into that because there's a lot of stuff in there, man. Stuff that's I'll just leave it at that.
Yep.
Anyway, so let's get back to Hutchison. So what do we think he did? And I'll just tell you mine, and then we'll go around and see what everybody thinks he did. Or maybe, you know what, Ben, let's start with you. What do you think he did?
Well, I thought I heard somewhere, and I was going to ask you if you knew. I thought I heard somewhere that he was putting multiple frequencies into the objects, or utilizing multiple frequencies, and I was wondering if maybe he was creating some kind of coherence frequency.
You mean like all frequencies that go together? Is that what you're saying?
Instead of like a what do you call it? Destructive pattern or deconstructive pattern, something like that.
Well, depending on which one he's working on, right?
Right.
So if he's trying to lift objects or he's trying to explode them.
Right, but do you think he was using multiple frequencies to accomplish what he was doing?
Yeah.
Yeah.
I do. I'm there with that one.
So that makes sense. Like Joe was saying earlier, some kind of standing wave.
Which would make looking at his equipment more understandable. If he's got a testicle and a frequency generator, then you need to look into his frequency generator and see if he was scrolling through certain frequencies. So it doesn't all have to come out of the same piece of equipment, by the way. Right.
And he doesn't tell us which frequency ranges he's working with, or do you think he keeps that hidden?
He doesn't say much about anything about it. He didn't even told you there were multiple frequencies. He simply just told you to get a frequency generator.
Right. I think you're right, though. I think people are looking too high in the frequency range. They might have to lower their frequency range.
Now we're getting there. What else do you see, Ben?
Well, we know that with the samples that we saw from the Cosmic Summit, that there's some kind of transmutation going on in some of his experiments, and it's changing the elements a little bit, producing that orichalcum, that purple color, that amazing, color that you saw in the conference. This just like it reminds me of what Malcolm said about orichalcum being the byproduct of the Atlantean technology. So it's all like kind of like fitting together historically, and I think we're going to see like this kind of technology is going to be the way of the future, But his sample that was presented at the conference. I think it was analyzed, wasn't it, for bubble cavitation or plasmoid cavitation?
You're talking about the oh my God,
for the sample that he brought to Cosmic Summit, or that was brought to Cosmic Summit by was it Grenier?
I don't remember who brought it.
I would think it would be. He's into that.
It might have been Grenier who brought the sample, or somebody he knew. But that it's just it's just a remarkable like piece of evidence that supports some of the historical theories that have been abandoned by mainstream science regarding like ancient Egyptian culture possibly being older than we're taught, and yeah. So this is all relevant to like the bigger picture of lost technology over time.
I think you're right. Yeah, Bob Grenier shows all that stuff, and he shows the actual pattern. By the way, the sacred geometry pattern that he keeps showing you it's just the frequencies. It's the octave scale. He keeps showing it to you, and people don't realize what it is. That's what it is. And then depending if you have a north and south pole, or just a north pole, or just a south pole individually, it changes where they show up in that scale. So just understand that he's showing you that all the time. And yes, it's sacred geometry, but it's also that frequency scale. And you have to realize that. And if you do, then you say, oh man, plasmoid, frequency, cavitation, not that hard.
Well, yeah, that makes sense because he's working on plasmoid unification model and everything like that. And that's all based off of octaves and frequencies. So none of that's all super surprising. What do you think about what Hutchison was doing, Nathan?
So what I think he basically did is use his Tesla coil in order to create a scalar wave in his apartment that's able to form out like a gas where he's able to hold in static electricity. I've done the experiment on the cold side. It works just the same on the hot side. So he's holding in that energy in there. It's bouncing around with the different frequencies in there. Okay. And then once it gets over to an item, it then saturates that item. When that item can no longer take any more saturation, it loses its grip on gravity itself. So he's not putting any propulsion method in it. It basically cannot stand to sit there any longer. Then it breaks from gravity in itself. So around that item is an actual field bubble. So when you see that bottle crush, when it has a lid on it, and then stay just fine with the lid open, it's not pulling all that, you know what I mean? It's able to pull all the liquid out of that bottle and get rid of it. And once all the liquid's gone and some of this stuff, then it lifts. You see, it takes several days sometimes because there's still liquid in that bottle or outside that bottle or somewhere around it. Once it gets rid of the liquid, then it loses all ability to stay in gravity. And that's what the field on the outside holds out. It holds out the liquid itself, and it has to do because he's creating diamagnetism in that environment. So he's changing the structures of your electrons in order to fit the field correctly in order to do it. Now, you could do it on the hot side, but you can also do it on the cold side. You just have to know what you're doing. One's more powerful than the other. So if I can create at 10 volts what you can create at 400 volts, then which one's more powerful? I mean, you really got to start to think about what you're doing there. He's definitely creating a plasmoid in there. There's no question about it. When he's blowing material apart, that is a plasmoid exploding in there. It's ripping things to shreds. And when it comes to lift, he's just using the anti-gravity effect, which is going to basically take your Tesla coil. It's going to take some kind of static field generation. If you're in hot electricity, you don't need magnets, especially with the environment being so magnetically charged in there with all the metal. If you're in a cold voltage, you absolutely need magnets because you do not have magnetism, because diamagnetism forces the field on the inside, so it defeats Lenz's law, where hot voltage doesn't. It keeps it on the outside. So just understand which field you're in and then adjust accordingly. But I think he created cavitation in that room without question. And it's one of the very most overlooked things that's going on there. And that's my thought on it.
So it's more of like it's negating gravity around the object rather than creating like an attractive force at the top of his ceiling.
That's right.
Yeah.
Okay, so I have a little bit of a hybrid on it, my take on it. And I agree with actually just everything you said. Now, I'm going to say that there could be multiple frequencies involved, but I'm going to stick with the fact that there's one frequency involved. Okay, and the frequency is deterministic of what's ultimately going to happen and what's going to happen when. Okay, now not everything happens at the same time. You have to achieve the field saturation of the room, like you said, and the environment in order for there to be a macroscopic cavitation bubble effect that takes place. Now, what happens is that depending on the frequency that's put in, everything in that vicinity is going to ultimately be in a state of forced resonance over time. So it's going to basically shake, right? Until it's shaking at the same frequency. Now, when it achieves that, okay, if it's intolerance of the material that it's made of, okay, and it's all through it, then the gravitation could occur because then there's an equilibrium that's reached within the object itself and the environment. And like you know, anything that's in a state of equilibrium is in suspension. Okay, so you're creating an environmental suspension within the cavitation bubble itself. So if the object has reached the same resonant frequency as its environment and it's tolerating that, it will then be able to move about, have reduced mass, things of that nature because of that suspension. That said, okay, if the native frequencies that create the field are intolerant of the material at hand, okay, is when you start to have more adverse effects. You know, you could have things that are basically molecularly rattling themselves apart, okay, because their crystal bonds are strong and being resonated at a frequency that's intolerant to keep it together in the first place, leading to deconstructive materialization, deconstructive interference and dematerialization of the molecular bonds of the structure. And that would create micro cavitation effects because of the collapsing of the small the tiny molecular bond structures. So you'd have like these small micro events occurring within the material as it's also happening on the outside too. So I think what you put in is critical, whether it's one or many. But again, I think one is a good way to think about it. I think in the example of the bottle, the plastic outside is in a different state of resonance as the liquid inside, creating like a literal differential, a resonant pressure differential within something contained within something else. So you have one material in a state of equilibrium and another not, and the higher pressure densities would ultimately crush in on the liquid inside. Now once that liquid were to be forced into an equilibrium with the rest of the system, chances are it would just go back to normal.
Interesting.
Yeah.
So I wanted to bring up something that Jeremiah said. And it had to do with a radar.
I can't read it. Would you be able to read it?
When I spoke with John about his setups, there were 3 needed parameters: a high voltage DC charge power source, a high frequency transmitter, can be a Tesla coil or a transmitter, and pulse to EM radar. I don't know the word. Clystron. Klystron? Klystron. Okay. What I found interesting about this is anytime they would talk about any UFO went down, the only innovation we came up in there was radar. And radar would mess up their frequency. So to put that in this experiment, if he did use some form of radar, then he would scroll the frequencies easily. So radar is basically just a resonance chamber in itself where you pull the frequency out of the side of the resonance chamber right there, or you can implement some other different frequency in there, but it's the same repeating frequency over and over and over and over again, right? And it creates a microwave out of it. So basically that I found that very interesting because it could be part of what's going on as well. So that's the only reason for multiple frequencies is if you were able to channel through that and create a very high level of energy. And it, by the way, what was that show? Skinwalker Ranch was talking about the, effect that was coming out of the ground, and it happened to be that it was a microwave coming out of the ground. And then they see what looks to be plasmoids, not UFOs, in the sky. Pretty interesting effect. So it's like lasers being shot at each other in order to create what looks like a plasmoid. But when you get to microwaves, boom, that plasmoid must be way bigger. You know what I mean? You're able to really put some energy into it. So,
well, I mean, radar is going to be working off a higher energy pulse type, behavior just in general, right? I mean, that's the whole nature of how it works, sending pulses out more or less, and the frequency range for it, it could definitely lend a hand in this. To bring that type of equipment into the garage experimentation is probably not as complicated as it kind of feels like at the forefront. Like there's just so many different I think that I've grown up working in a boatyard my entire life. I think I saw piles of radar systems just like sitting there doing nothing, Raytheons and the whole 9 yards just piled up on the side of a building. Like, to get your hands on this stuff is not any sort of complicated endeavor, which is kind of the good news,
Sorry, I'm reading the comments.
Yeah.
So, if you want to do it in the garage, I would suggest you start with a metal box that's big enough, 3 feet by 3 feet, and then run all of the energy into it. And that just kind of create the same environment that he had, whether it was in the cargo ship or whether it was in, the room with all of the equipment around. That'd be a starting point. And then obviously you're not going to put some masterful voltage in there like he did. So if you're going to go low voltage, obviously the room size would make a big difference in it. So you have to be much smaller. And then get all the equipment that he says, put a frequency generator in there, captivate the plasma coming out of that Tesla coil. Do not let it discharge into there. You need the field, but you do not want the plasma. So if he connected his Tesla coil, by the way, to a plate, like an aluminum plate, there wouldn't be any plasma in it. The charge would be completely on that plate. If he used bismuth, oh my, now we're having some fun, because you already have cavitation in there and you already have the diamagnetism in there. Now you're amplifying. So let's see. So Jeremiah says, let's see. So here's what I think happens. The pulse will knock the electrons loose off the material lattice. The transmitter keeps the electrons abound, and the high voltage DC pulls the electrons out of the material. So, funny thing, I talked about this before, and I may be wrong, so I'll just put it out there up front. I think the electron effect is basically your magnetic field that causes everything to cog. And when you remove them, you lose that field. So you go into the diamagnetic. So then now it inverts the field. So now Lenz's law is no longer affected. So if you can look at an electron that way, that it's not always needed in electricity, then it makes perfect sense. If you're one of those that believes in electrons everywhere, if there's electricity, then it won't make any sense to you. But
yeah, I mean, so Jeremiah's now saying, he's saying that allows the release charge to cluster, which would destabilize the material structure to allow the charge clusters to do their work. So, I mean, again, that's something that I wholeheartedly, agree with. And that's what I was saying, is that once you have the destabilization of the crystal structure at the molecular level, you create these voids. Those voids are going to lend themselves to charge cluster. That's where the charges are ultimately going to accumulate. That's what plasmoids do. They bundle up, and then they start working their way through the material. And that's why, even when you're looking at some of the like that other picture that we were looking at before, right? That's how you see all the cavitation that was occurring on the outside of it as well, because it's trying to create a little like place for itself to accumulate. Those are all its spots of accumulation. So we didn't talk about or really realize maybe the radar element of that, like you brought to us, but that makes total sense too, because those pulses are just going to act to accelerate that accumulation without depending on ambient saturation to work its way. It would speed up the process, that's for certain.
I found those pictures, by the way, that the gentleman sent me from Cosmic Summit of the Ori Chalcom.
Okay. I just want to give reference to this picture real quick before I take it off. Tim Ventura put this up, and it basically shows the metal that was torn apart. And right here, John mentioned that that's high RF damage. So that would fall in line with this Tesla coil being so high. You know what I mean?
And almost then looks like it's melted.
Yeah, all the RF in the room. That's testable, by the way. I got a Tesla coil that puts out the same frequency all the time and has a massive monster field to it. So that right there, that's testable. We could see if we couldn't blow some stuff up with that. So I could put a lot of voltage into that one too. So Anyway, that was just an idea. Okay, Ben, let's see what you got here. I want to see the goo.
So these are some pictures that the gentleman, I don't know if he was the owner or caretaker of the sample at the Cosmic Summit. He sent me some pictures, some high quality ones that you can kind of see that the purple is very, very beautiful purple. I just wanted to show you guys real quick because it's, you can see the same kind of melting or stretching of the metal there in the middle. But the color is just like some of these, transmutations are really incredible. I think Malcolm even said that if you look close enough, you see like little gold tubules.
Can you zoom in on it, Ben?
Yeah, let me zoom in on it a little bit.
Am I the only one that finds that surface wrinkling to be just as interesting as like the, delamination of the internal crystal structure of the metal?
Yeah, that's very interesting.
Yeah, that is interesting. Because how do you cause that?
No,
Other than what we're
otherwise it
saying.
looks like a normal block that's would have been smooth on all sides, right?
Absolutely.
It's just I just thought like these samples, they're so interesting, and the purple color is just really, really beautiful.
Well, aside from the color, I'm not trying to correct you, Ben, but just for the purpose of being accurate, I think like it's not a melting effect that's occurring, and I think that's pretty evident based on that type of striation that
Oh yeah, for sure.
it's not melting. They've noted it as like a jellification. They've described it as and then as soon as the energy source is kind of turned off and saturation is gone, then I guess there's a solidification event that would occur, where it would recrystallize at that point, but just hold that form.
Yeah, it's like jellifying and then kind of stretching apart.
Yeah, and I mean the internal forces and torsions of the deconstructive interference and the plasmoid inclusion, would probably be like, I mean, what happens to the material is interesting. The fact that it pulls itself apart in such a manner is, to me, the most, I don't want to call it mysterious, but the most incredible part of it. Because like that's a real, like it's one thing to change the structure of the material itself internally, let's say, where if you were to cut it open, you're like, hey, look at what this did. This is literally dematerializing itself in points. So I think that's.
Yeah, I think one of the most important parts that I forgot to mention too is this was a copper bar. This started out as copper.
So, that's copper?
That's what Malcolm said. This was a copper bar.
Wow. What? Okay, is it just a camera effect that's purple? Is that what I'm seeing here?
The shade of purple, yeah. It might actually be a little bit darker purple than that in real life. I'm not sure, honestly. It's hard to tell, but based on observations from Malcolm and Bob Grenier, it's supposed to be purple.
Well, I mean, when copper reacts with different chemicals and stuff, and it's in solution, just it's often a blue solution, right? Blue, like an indigo blue solution.
That's true.
I mean, there could be some sort of not oxidation necessarily, but some type of surface chemical effect. If there was in fact some sort of, I mean, now I'm getting very highly speculative, but if there was some surface level transmutation that was occurring, and then it was just being forced into molecular bonds with the copper at the surface, you could have some kind of compound on the surface that's not just pure copper. Like I don't think it's a matter of turning copper purple.
Well, copper is very malleable, so it's not out of the realm of possibility to believe that it might be malleable with frequency as well.
Well, I think that Hutchinson's tests show that the malleability of the material is completely irrelevant to the reaction, because he was taking stainless steel bars and doing the same exact thing.
So just so we know, the table behind it looks a little purple, so I think it's a tint in the camera that's making it more purple.
I felt that way too, but I didn't want to say anything to that effect. But yeah,
Yeah, I think if anything, that copper would be green. You know what I mean? Something like that, kind of like Statue of Liberty, kind of putting it in water too long.
Yeah, but that's an
So,
oxidation effect, and I mean it's not completely unbelievable to believe that it would go purple-ish under these circumstances. I think that for me, if it's on a black background, well that's a purple, black, navy blue. So somebody was up in the levels, I think, in my
yeah.
opinion. But
So
who am
it
I?
says right here, check this as comment. I'm sorry, Joe. You could push your finger into the metal after treatment and it's not hot. That means it was high RF. There's no question what that is.
Yeah.
If you're creating a high RF to create a plasmoid, that's it. That's the effect. That the metal is touchable and it's not hot. High RF goes away as soon as you turn off the Tesla coil.
Yeah, I mean that could also be that purple could also be a form of tempering that occurred, and it could be
or contamination.
I mean, it could be manifest like precipitation of the contamination, like they'd seen in other experiments. And this is all highly speculative, but I've seen copper turn purple before when working with heat. So, and that work, anytime you're changing the surface color of a metal, it has to do with the tempering of the metal, the molecular structure of the crystal itself as to whether it's malleable or brittle or workable or so on and so forth, right?
So you're talking about a welding effect on aluminum?
Well, not a welding effect necessarily. It's like a tempering is a
when it's super hot and you put it into the water.
When you heat metal up,
Okay.
it cycles through different color shifts. The color shifts represent a crystal reformation that will, depending on the metal and the temperature, will give you different attributes to the metal, right? So during like a heat tempering, or even if you're just soldering a pipe, let's just say in the context of copper, right? You're soldering a pipe, you got the torch on it. The copper pipe changes colors as it goes through different temperatures. So I'm not saying that was heated, but what I am saying is that there could be, like you alluded to, RF interference at the surface that's creating a difference in the molecular structure of the surface of the material, because how is that implausible when you're looking at the center of this thing literally being chewed apart, dematerialized, and broken molecular bonds? So to think that the surface couldn't go through some type of a non-heat related tempering process which is molecular restructuring that's silly. Right?
Well, yeah, we know what hot and cold does to material when you put it in there after you heated it. Well, this is just a different type of energy being put into it. So, yeah, I would expect something different.
Yeah.
Interesting. So, Ben, did you have that goo picture?
You said what?
Or the goo picture? Did you have one with goo on it? Or was that the color?
Those are that's the only ones that I have. I haven't.
Okay.
I thought I had a couple more. I don't know. They might be lost in my hard drive somewhere. But they were pretty much all the same sample.
Well, let's take a look at this one then. I got another one.
And I want to throw that out, that 8 center saying, it could be like anodization as well. But anodization is a secondary process. So if it's purple because it was anodized, then it's fraud. So I'm just throwing that out there. I don't claim that I know what it is.
You know what this reminds me of, these pictures? Those people that take those TV parts and they put it up to the sun and they magnify a rock and it melts? That's basically what this looks like to me. It's like a Play-Doh, but it's in hard material.
Yeah. Weird, because it begins to look like more organic in nature, when it undergoes that process.
What kind of material is this?
Brass?
Just
I would
brass?
imagine it's brass, but I don't know that for sure.
It looks
I
like.
think I saw this example. They said it was brass.
Yeah, that's interesting, man. That stuff is. I guess we'll find out. You know what I mean? When we get to a very, very high, level like that. Just so you know, guys, when I was doing my resonance experiments with my Tesla coil, it kind of freaked me out that this was going on. So I usually put my Tesla coil in random voltages, stuff like that, and frequencies in order to test for various things. But since I was looking for pure resonance, okay, the perfect kind, I had set my Tesla coil with my primary being perfect now. It's set exactly the same amount of windings around, distances are perfect, everything, right? So the resonance that it puts out is so much better. And then we used that switching bank that Ian sent us, right? It pulled that thing in perfect resonance, okay? I could not run it over 13 volts or 14, 13, somewhere in that area without a very high problem in the room. Every surface was hot, but it was cold to the touch. So, I mean, it burned your finger, but it was cold. It was the strangest experience. So there was a huge amount of RF being in the absolute correct frequency of that coil. So I 100% understand that that's what's going on here. So you wouldn't have known it unless you did the test, and it was like, wow, that was too powerful. I would have to push that thing down in voltage lower. You know what I mean? In order to get rid of that effect. And then the plasma, it ruins the effect. So if I could captivate that plasma that comes out of that thing, I could push that field even further. That's one of the main problems. It's using up the energy in the room. So, yeah. Yeah, it's crazy how that works.
Yeah, Creating Awareness said, research the work of Ken Schollers. He worked a long time with John Hutchison. Yes. He knew all about the charged clusters.
Yeah. Well, I guess if you just focus your experiments on it, and that's what you do for the next month, it's achievable. I mean, any frequency you want on a Tesla coil, I mean, you could do it. I'm going to build one here in the next few days that's going to be 1 megahertz, and then I'm going to do it 1 megahertz plus 300 kilohertz. So, you know what I mean? If you want to run it on a gravity flyer or anything like that, you could basically put the rod down the center and it would drop to 1 megahertz on its own. So it'd be perfect if you were looking to do that. Now, you could choose your way to think about that, but I would personally rather on that, because it's cold energy that's lifting it, it would be lower in frequency. I would try to get down around 20 hertz, maybe 10 hertz on that frequency itself. But that's just my opinion. But I know everybody wants to lift it in hot energy because that's the way physics says to do it. The calculations, by the way, we were listening to Phil do the calculations on this.
Oh, they're wild.
Let's just put it this way. Your wire size is about the size of your truck. And then you'd have to plug that into the actual energy station in order to get it to work.
Well, it's like that guy you had on that one time talking about terahertz and stuff all the time. And it's like, oh, great.
Dude, you can get a terahertz frequency. That's not a problem. The coils are like this big. Here's the thing. They're like this big. It's not a lot to it.
What's the lowest frequency that you can get on the Tesla coil? You said you can go down to like 10 or below hertz?
I've got one down to 20 hertz.
20 hertz?
That's as far as I can get it down.
Yeah, that's still pretty low, though, for a Tesla coil, right?
Oh, that's unheard of for a Tesla coil. I doubt you got many people that can match that. Don't get me wrong. I'm sure there's people out there that could. They know what they're doing, but I've never seen it anywhere else as far as I know.
Yeah. Like Canadian hot rocks. Truth, man. There's a lot of different crazy like ores and stuff that they have in BC that could be
like
a thing.
Tesla coil building competitions and stuff like that.
Maybe I should enter one of those. I could do that.
You'd totally win that.
Hey, I want to bring something up real quick with the Hutchison thing that just came to mind after like kind of playing with these photos and videos in my head a little bit. Whether it's like something dematerializing and twisting about and doing its thing, or it's something levitating. What I realize is that analogous to like the thunderstorm generator, for instance, right? That there appears to be an event horizon, so to speak, in the objects that are affected. And it's not always like where you might think. It's not always like dead center or anything like that. But there's some sort of like internal circumstance that's occurring locally within as the effect is going on. Like when you see the wrench pick up off the table, right? You would think that if it's just like, okay, if it was just shaking and breaking loose, then it would just lift up, right? Like a magic trick from the 1800s when they're like having a seance and someone lifts off the table. It's not like that though. The thing lifts up, but then also like straightens. It's sort of like it has a new center of equilibrium within it. And I'm not calling it a center of gravity, because that becomes irrelevant when you have something levitating in equilibrium with its, whatever. So it's not a center of gravity at that point, but it's a center of whatever charge is affecting it, whatever resonance is affecting it. Okay. When you look at the dematerialized pieces, some of them start breaking at the end. That last piece of brass that you showed tied right into what Jeremiah was saying about charge clusters. It was pretty apparent that you have a massive charge cluster in the center of this thing, and after it did its work in the middle, it almost like ate it all away, right? It actually shoots outward, and it's almost like that discharge of it not like blew it apart. Like, I'm just trying to imagine like the forces at work that would be causing that through charge clustering. The whole point is that each different object in those are finding within themselves a locality and a place of equilibrium within their own small, their own small systems, their own self.
Yeah, I wanted real quick. Let's see, sorry. My mouse is acting up right now. All right, Jeremiah said, I forgot to mention, John was a fan of having some radioactive material in the near target area. It was just the ionization, which then becomes cold plasma in an RF excited. Oh, there you go.
Guarantee he learned that secret from Ken Shoulders.
Interesting.
Yeah, ionizing radiation in these high saturation fields is definitely it's a thing. It could definitely add to the effects, I'd have to say.
So let me ask you guys this.
When it comes to charge separation, my bad.
That plasma that he had sitting in there that was cavitated, he might be putting, x-rays out of that. You know what I mean?
Sort of my assumption is that, that it was getting up into like very, very high frequency bands.
Yeah. I think there's more to that, because when you create cold energy plasma, it also creates x-rays. So, and you see it, if you're outside and it's say 30, 40 degrees, and you use that cold energy, put the rod down the center on the wire that comes from that rod, you can touch it and it'll go blue all across it, right? It's putting out some form of, radiation or something like that out of it that's blue. And then when you get into Tesla's work on his x-rays that were safe, you have something more there. So I'm just saying it's all part of the same cycle. So John probably used it in the hot energy in the same way.
I think Ian had a question.
Yeah.
Okay.
Right here. This one?
Yeah.
What happens when...
I can't.
Sorry. No one's got me reading, the bad reader in the bunch. All right, here we go. What happens when you create a standing wave that prevents the material from naturally holding its form? Does it return to the source and the produced energy? Perhaps cavitation does that too through acceleration.
I mean, I would say at low levels, it doesn't have any reaction. And that's why these things take time, is because, to bring something into forced resonance with a closed system, so to speak. Closed system meaning like a bubble of saturation, right? It takes a long time, just generally, I would think. I think that's where Jeremiah was saying, like, having pulsed radar and stuff like that might help accelerate that process. But if it's not in resonance, and it's not strong enough, I don't think it would have any sort of adverse reaction. You may see something like it's shaking, or in frustration, something like to that. Like it's only at the higher power levels that you would start having the greater effect, I think. And I think that it would always start on the smaller scale before the larger scale. So before you had any sort of negative effect, if it wasn't going to have it, you'd get the levitation, right? If it was going to have a negative effect, it's going to start tearing apart from the inside out, okay, before you even realize it's going to happen. Those are only at the higher power levels of saturation, and enough time for them to sort of marinate in it and determine whether that power level is going to be sufficient to affect that object or not. If it's not powerful enough, then I think that it would either just kind of do nothing because no molecular bonds are being broken. And I think that once the chain reaction, so it will kind of put my foot, my foot before the other. I think that once a molecular bond is kind of broken, okay, that isn't necessarily a cascading effect, but it's an accelerating aspect, because that one break would promote charge cluster, which would cause another break, which would promote great, advancement of the charge cluster. So I don't know if that 100% answered that question, but I kind of hope it did.
So, real quick, depending on how you see an electron working, right? If you said the plasmoid was like an electron and we had to expel all the electrons out of the field, then if you built an electron in the center of each one of the items and it had to move itself out of the field, and the quickest way to move itself out of the field was going up, that would make perfect sense as well. If you could see it that way. Not everybody would. But if you saw it that way, then yeah. Also, with the cavitation and stuff, rotation will increase the energy level of it and put out a stronger field.
Damn
so
right.
When you put your Tesla coil connected to a rotating disc and you can speed and slow it, you can vary the distances it goes. So just so we all understand that, that's a pretty easy effect. So spinning it faster pushes out the field, right? Spinning it slower brings it in. So yeah, and then you put it in cavitation. If you're spinning cavitation, you're basically spinning capacitors. So, and you're getting capacitor discharge from every time you spin it. Not that the Hutchison thing does any of that. I'm just saying, to answer the question a little bit more, the rotation is important for cavitation when you have energy inside the cavitation in order to force it out. In order to cross that distance between the next level, you're going to need it. So
yeah. When you're dealing with intramedium cavitation, then yeah, that rotation is going to be a critical component. The rotation could also be simulated through field flow and compression, but the level of efficiency and correct geometry needed to have those high levels of power and compression, it's that's sort of the trick to it, I'd have to say, right? That's sort of the the rabbit out of the hat for this subject and conversation. If you add the mechanical spin to it, it definitely breaks a barrier as far as having to have perfect flow of an electrical component. So that's a thing.
So real quick, the spin does not have to come by physical rotation, by the way. You can do it in solid state.
You can do it in solid state, sure.
You don't even have to have rotation to produce cavitation?
No. What I'm saying is, so let me clarify.
Mm-hmm.
If I ran the coil in a certain direction, right?
Mm-hmm.
And I have spin in that direction. Now I already have spin without physically taking a disc and spinning it, right?
Oh, right.
So depending on how you build it, and Gerald talks about this, you got, one side and the other, one pushes one way, one pushes the other, but it's multiple levels of it, and they push like this. And as soon as you turn it on, this is what you get, one after the other, right? Goes one,
oscillating.
then it goes two, yeah. So you don't necessarily have to physically create the rotation if you do it in solid state the right way. So,
interesting.
And by the way you wind your coil matters. So if, how do I say this? When you just take a basic coil and you want to wind it to push a magnet, well, you wind it one way and it'll change the north and the south on it. You wind it back the other way and they're opposite of it. So just keep that in mind as you do it. It matters the way you wind your coils. So it's just interesting effects, but that's kind of why I do my experiment the way we're going to do it is we want to create the cavitation. That was the whole purpose of it. The cavitation, the multiple energies, everything. And by the way, we've been watching some bismuth. I know I've been like really getting into it on what this stuff is doing. And it's because of that field flip that it does. It's why it's so important. It's when we basically found out how we can take energy, put it in water, and it affects our crystals. Now think about it in the same way of this, where you have two like energy sources. Now one amplifies the living daylights out of the other. That's where that spike occurs. You put that in close cavitation. Okay, you saw the UFO fragments that they did on Alt Propulsion Channel. He talks about it. And they were looking at it. You had aluminum, bismuth, aluminum. There's a very specific reason for that. And it has to do with the cavitation. It has to do with the cold energy that's in there. And then it also has to do with the eddy currents. So, in the way that they're forcing the energy out of it and creating that bubble and that field. So think about it. If your Tesla coil is creating the field bubble we always talk about, then amplifying that energy with bismuth makes, boom, all the sense in the world, right? But then you need cavitation on that so that it doesn't blast out to the world. You need it to stay in that area, so it forces it to stay.
Well, it's sort of like if you were to take a piece of rope that's short, right? And you meet it in the middle and then pull it and you bang, and then you got to go like this, right? The piece of rope. So that's what it's doing to the field is, it's one side of the material of the paraelectric, the paramagnetic is drawing, kind of pulling it in, and then the other side is pushing it out and pulling it in and pushing it out, and it's this constant state of reverberation of the field that keeps the containment.
Yeah, because eddy current, by the way, is very weak. Just so you know, it does occur, but it's only going to push out that field so far.
Mm-hmm.
So, just so we're all aware of that. And then when you start looking at stuff that has to do with diamagnetism, you start looking at water and glass. And by the way, isn't it funny that all the stuff in the one wire energy did was water, glass, stuff like that, how it reacts to it. It's why it's important. So we looked at cavitation with the burrito. We looked at the glass and how it reacts to the energy, why it's reacting to it. So it all makes sense in the bigger picture of things, by the way. So at least that's my thought process in building this thing.
For sure. The fields all matter. The materials matter. Who just said a second ago about Sapphire Project?
I'm sorry, where is it at?
Oh, okay. John Bigman. He said, did we check out the Sapphire Project yet? I mean, I've seen Sapphire Project before, at least some older material on it. I know that there was a little bit of controversy surrounding it at some points in time. They're having some difficulty with funding and just their team in general. But yeah, the entire principle of their microstar that they were building is exactly the same principles as all this too. It's, and what they described was going on in their fusion event is exactly what we were just saying about this cavitation event being this pulsing expansion and contraction, continuously. So it's right. It's exactly all the same principle, across the board. It's all just a matter of everything in the universe pretty much works off of these principles, right? So yeah, it's not shocking that there's all these different ways to go about observing the same effects. The thing is that they all make the same claims and they all work off of the same exact principles. So, you could dispute one thing, right? You could say, this whole, pulling the energy out of the 0 point this way or whatever is total fiction. It's something you can't do. Okay, but these are the observables, right? These are the things that we know happens. You also know that the more you put into like a coil, like a Ronin coil, for instance, right? Right. The more in resonance and denser you get it, the tighter the field's all put in until the point where you almost have no external field. It's all really just pulling into the center at that point, right? These are things that we've established. It's no different. When you start, jacking up the the input, and it's just pulling closer to the center, and it's actually at a higher resonance in terms of, it's collapsing and expansion events, right? This is a thunderstorm generator, same thing. Star in a jar, same exact thing. Sapphire Project, same exact thing. That's it. Hutchison, same exact thing. So it's you could naysay one of them, but how do you naysay all these things? Like, I guess everybody is just doing it a different way, finding the same exact results, the same exact mechanisms, and then saying, well, yeah, but this isn't the case. Like, well, at what point do you throw your hands up in the air and you're like, who's the fucking idiot here? I'm sorry.
Yeah. Well, some of these things, and I gotta say this from replicating people's stuff and then everybody wanting some things to change. Please understand this. If you're going to reverse engineer something, reverse engineer it the way they did it, not your interpretation of the way they did it. That's one of the most important parts of understanding how they did it, because your version is going to be missing something that the original version had. And unless you look at it that way, you're never going to get it right. I think a lot of people make that mistake. They go, well, I wanted to build it, but then I wanted copper instead of aluminum. Or I wanted, steel instead of the aluminum. And you never stop to look at why the aluminum's there.
Oh, yeah, they want to take this shortcut or that shortcut, or they got a better idea. I could improve this a little bit here, and you don't follow the instructions fully. That's
right. And there was one guy that said that famously. Who was that? Dollard. Dollard says that he followed what Tesla did exactly. Didn't change it, didn't mess with it, just did it the way he said to do it. So always something important to look at, huh?
Well, isn't that two sides to the coin? Like, you should follow that to get the same results for the purposes, in my opinion, of being able to learn what they've learned along the way, get to where they are, and then pick up where they left off, and then you could start making your tweaks and whatnot. But you can't sit there and look at what they did, recreate it, and then say, but it didn't work. Like, that's just not the way it goes.
It's not fair.
People should always, follow that intuition and that curiosity that's going to bring them, to that next point, but not at the criticism of somebody else's work.
Yeah.
If you didn't do it the same way.
Yeah, if you didn't want to criticize the work, build it any way you want to.
Right.
The world is your oyster.
Right. And you got to remember something, like, if you drive a car at sea level and you turn the key and it starts right up, right, on a 70-degree day, right? One crank and it starts right up. You drive down the road, you have 375 horsepower at your disposal at sea level, right? You take the same vehicle, you drive it up to Colorado in the mountains. You just lost a ton of temperature. You have less air, pressure, and because of your altitude, you go cold start it, the thing's before it ever bites. Then once it bites, you're driving down the road and you have 225 horsepower, same exact setup. And you got to remember something. Environment is a real thing. It affects every single thing around you. So even if you did an exact replica of what somebody else did, just it being in the same place at a different time is enough for there to possibly need some type of adjustment to achieve even a fraction of the same result that was documented at one point in time or another. These are just things that have to come with the territory. And, getting a different result under the same circumstances is not necessarily indication of a failure either. And I don't think that people are quick to really want to believe that because they put in time, money, and effort and belief and all this stuff. So when it doesn't work exactly as is, and they've already had the frustration of getting to the point where they are at testing, they throw their hands up in the air and just say it's bullshit.
No,
I think that happens all the time.
So many days, man, where I just want to BS everything. I'm just like, F this, F that, a couple other swear words in there. And I get mad. I got burns all over my fingers. You know what I mean? And I just didn't get the concept behind it. And it took go getting a sandwich or, soda pop or something to get away from it to go back to it and get it right. So trust me, those days happen a lot.
Yeah, when you're facing like engineer's block, I guess that you would call it.
Yeah.
I find that like stop thinking about trying to force the idea and then let it come naturally when you're not thinking about it. That's when you get your best ideas, when you're not even trying to think about it.
Yeah.
Inspiration comes in all different ways for all different people, and and it doesn't hurt to have like a group of people that are like this group here. There's so many people here that have so many different baselines of knowledge that they'd be quick to say, hey, here's a couple of references like to look at, maybe this will help you along your way. And you watch and all of a sudden it's like, hey, wait a second, now I'm seeing things way differently than I did 10 minutes ago.
Yeah, my research would not be where it is today without this group. The chat, the Fringe think tank, everybody involved. I wouldn't be where I am. So, like Malcolm likes to say, we're all standing on the shoulders of giants. So we gotta not disappoint them.
Yeah.
Okay, real quick, I just want to show something, and then we'll get back to the Hutchison effect real quick. I just wanted to share this because I'm excited, and this stuff takes forever, by the way, to print. But that's where I'm at so far. So I have the other side of the second one out. You see the middle one has it. The outside one, I got to run one more 16-hour print to get that done. The black sides or the opposite sides to them, I have all of them except for one. So it's a couple more prints and we're good to go. The cool thing is all those little holes you see, the bumps that come up, those are basically for insets. I'm going to put insets in them so we can bolt things onto them on the outside. So that black layer may be a shell right now, but it could be aluminum. It could be bismuth. It could be a composite of both. You know what I mean? It could be anything that we want. So
I was kind of thinking maybe you would put like LEDs in there and you'd have like a spinning disco ball.
Not quite.
Yeah, I think something like that would be rather hard to balance. It might look great, but
yeah,
juice ain't worth the squeeze, I don't think.
No.
I think that's not the glow in the dark plastic, is it?
No, it's just white.
Oh, okay. But I think that would be cool if you got a glow in the dark one at some point too.
Well, that's good too, because white probably has titanium oxide pigment in it. So you probably even get like a little bit of like a K value off of that, right?
So Jarvis said that he found a perfect way to electric coat, but it's a secret for now. Well, you might have to take your secret once you're ready to release it and put it on that layer. You know what I mean? So, yeah, it's interesting because we're going to, just like all this other stuff, high statics, high, you know what I mean? Stuff like that inside there. But anyway, I'll get back to the
If you want to electrical plastic, I know how to do it, like in theory. Yeah. It's not hard. You just have to get a conductive paint. And once you have to spray a conductive paint layer on it, and then you can just electroplate it like anything else.
So we got ceramic bearings. Someone said to use. I think on the second version of this, that's what we're going to go with. So I just used basically a skateboard bearing size, just so you guys understand. But yeah, if I can find them and do them before I put this thing together, I'll do it. But other than that, I want to rotate it. I want to see the magnetic field. You know what I mean? I want to see certain things as we build it and take it apart. So I won't seal everything completely with glue until we get a couple tests in.
Yeah.
You say that you got a thermal camera as well?
Yeah.
That's awesome.
We're going to be able to see each one of these layers, hopefully.
Ben, you didn't see the wire down the middle of the down the middle of the Tesla coil? The thermal camera? You didn't see that video?
I don't remember.
Oh my, there's no way you'd forget that, man. It was ridiculous. It was working like an X-ray. Which goes to show the level of temperature differential, that exists there, because it's like, the rest of the Tesla coil was definitely, much warmer than the ambient environment.
You know what? Come to think about it, I think I do remember that clip. Yeah.
Yeah, it said the shiny stuff is what shows up. And I showed aluminum rod right there, but I have copper rod. I mean, excuse me, not copper. I actually have the brass rods for it, is what I have sitting on the table. It just that was the rod that was available sitting next to me. So I showed it with that, but I have the brass ones ready to go. So, and then I ordered some brass balls for the for the center. It only takes one, but you got to order them in pairs. So I got a pair of brass balls coming.
You know what? Get you like a little stack to hold them in.
Did they come in a sack?
Dude, if they did, I'm showing that on the video. I will show everybody the sack with the brass balls.
The brass ball sack. Come on, it was at the tip of everybody's tongue.
I don't know that it's at the tip of my tongue, but that's okay.
Yeah.
I try not to keep ball sacks there.
I just got a picture. Like those chipmunks that store the peanuts in their cheeks?
Oh, no.
Yeah, you gotta hang the brass ball sack off of the brass rod.
Oh. You imagine that? You show somebody that you're sanding your rod, and then you have to put oil on it, and then you put the brass balls on it, and then you say it goes in this area so you can create the energy out of it, and you start going like this.
Well, listen, if you sanded it, you better give it a little spit shine afterwards,
Oh, my. Oh.
Yeah.
Oh.
All right, well, this project will be coming in no time. Anyway.
Lots of teabagging going on.
Oh, man, at least it's lively, huh?
Oh,
Bunch of schmucks.
Oh, my God, you must have read my mind. I was just thinking about the Jack emoji when he said it.
I put the Jack emoji for all the members out there, guys. It's in there. It's funny because on your screen you see like the emoji. On mine, it says schmuck, 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 schmuck. It's hilarious.
And it's relatively the same effects.
Yeah.
That was all good. I think it was Ashton the other day. He showed a clip with Jack in it, and everybody in the chat was like, "Schmuck, schmuck, schmuck." I was like, it transcends channels.
Oh God! I had no idea. That's hilarious.
Oh yeah,
Oh, man.
everybody knows about Jack and the Schmucks.
That's funny. Oh boy.
Oh, that's so great, man. Anyway, all right, let's get back to a little bit of the Hutchison before we end the stream, man.
Yeah, I mean, but that said, hey, like if anybody in the chat, like, there's a ton of people that are like, I know someone who knows him. I know, like, listen, if you have a connection to Hutchison, he'd make a wonderful guest on this show because he's a character, just generally. So, I mean, if anybody knows how we could get him on here to actually talk about these things, I don't know how much he wants to talk about it publicly or not, but you know, if anybody's got that connection, you want to throw it our way, please. I would love to be a part of something like that, you know. And I think that Nathan and I would be able to break him open in a way that's both engaging and very informative, and maybe get some new information out there. So
Bernie says he's interviewed Jack Safardi 10 times plus and yet to be called a schmuck. I can guarantee you right now, he would call me a big schmuck every time he talked to me. There's no getting around it.
That's all right. I'm the king of all schmucks, so.
Oh,
You did away with our names at the bottom. Remember, you used to say I was the community idiot. I like that designation personally. I gave it to myself.
oh, yeah. I think we all agree with you, Bernie.
Yep.
But I don't want to get on anybody's bad side. So anyway, I think what we need to do on this channel, though, I know everybody covers all the big names in physics and stuff. I think I want to go in the opposite direction of that. I want to get people who are doing inventions like us on the channel. You know what I mean? I just, I love the wine bottle, by the way. Negative Reds coils. He does it, and that thing is just awesome. He has a Tesla coil that's a wine bottle, and he's literally growing crystals inside of it. I mean, how cool is that? I mean,
yeah, that's awesome.
Those are the kind of people I'd like to get on. You know what I mean? The small-time inventor in the garage, come up with a new breakthrough. I mean, we can all recite physics terms, on other channels. I think that's best for them. But I think for us, it's the Fringe think tank. So who's on the Fringe? You know what I mean? I think what we should do, and, Joe and I talked about this, maybe on a Thursday or a Sunday or something like that. Every other week, we'll just have inventors that, kind of watch the show. You know what I mean? Email me. All you got to do is go to my page here on YouTube, and the email's on there. Email me that you want to get on, and we'll work it out. And I think that's going to be best. You know what I mean?
Yeah, that's going to be awesome. And I think it gives it's a little more organized than just an open mic. It'll give time for people to get their ideas together, in preparation ahead of time, and really give a good opportunity to get what they're doing out there to a solid group of people. And obviously people here, there's connections all over the place. So, have your stuff be seen. I think it's great. And if you know anything about us, we're not exactly judgmental like some other platforms that do that sort of thing, and give you the time of day and say your piece, whether we agree with you or not. Show your work and it's all good, right?
Yeah, that's pretty much it. So what I'll do is I'll just set it up this way. Not this Thursday coming up, but the following Thursday, whoever's got the invention and they get a hold of me in my email, we'll try to keep it to like 4 people on that day. If we get enough people, we'll do it again the following week. You know what I mean? But I'd like to see your guys' inventions, what you guys are working on, how you see things. maybe there's things that you can add to the conversations that we have on here, or maybe you disagree with them. That's fine too. As long as we all keep it civil, I'm good to go.
Yeah, right. If you have an opposing viewpoint or a theory of your own, that's maybe not something we discuss here. Step up and talk about it. This is an excellent platform for that too. And again, have your word get out there. I think that's awesome.
Yep. And yes, Thursdays. I think Thursdays we're just going to start it new. So I'm going to ask a couple of people that I watch and see if they will come on. If they'll do it this week, then we'll do it this week. You know what I mean? But I want to just let everybody advance warning. You know what I mean? Give them a couple of weeks to get ready. So, yeah, Thursdays. I think that's the way to go. And we'll get a lot more people out there that show us their inventions, and we'll change everything. So can't just be all of us doing the inventions. Anyway, that was just something I wanted to bring up. And then we were also kicking around a members only stream. So if you guys are interested in that, throw it out there in the chat, and let's look at it, and we can hook that up. And then I'm sure you can pretty much ask whatever you want. I'll make sure it doesn't go out on YouTube, so we can, try to keep it private.
Have it like a live Q&A. We can talk about medical stuff. Under those circumstances, we can go into spiritual aspects of this stuff, because I'll tell everybody right now, they ought to know it's my belief, like spiritual alignment and this type of work go hand in hand. We should really be able to address people on a one-on-one basis, or any questions of anything that comes up there, where we're not having to navigate through a whole subject matter and pick one and two things out of the chat, to bring up. But great chat participation as always today. I love watching the stuff come in. When you put it up on the screen, I can't read it. It's awesome stuff, and it's only going to get better moving forward, I think, based on what Nathan and I were discussing.
So, Joe, real quick, 8th Center. Have you seen his work, right? You have?
Absolutely. Yeah, I've seen his Organites, yes.
Okay, so, look, I'm sorry if I ignored the email. I get a lot of them. I'll have to find a way to sort them better. But I will absolutely have you on to talk about it if you want to. So,
yeah, I would have already shared his work, but he did politely ask me never to share his the photos and stuff for the purposes. He'll explain. I don't want to steal his thunder on that subject.
That's not a problem.
Right. And as this podcast expands, the chat's going to get more and more busy, and emails are going to get busy. So, every once in a while they're going to fall through the cracks, and, we apologize if we don't get to everything or we forget to come back to something, just remind us, hey,
Yeah. As things grow, though, we'll figure new ways to navigate this stuff and become more efficient with, making sure that people are, if you want to get on and stuff like that, that it's all being addressed.
Exactly.
Yeah. Oh, by the way, there was 2 more on there. I don't know on the emojis. By the way, here, I'll put them up. We have Top Secret and Conspiracy, and obviously Admiral Jack. So Admiral Jack, by the way, is from the Star Trek episode that we showed on Saturday. Absolutely hilarious. He just calls everybody schmucks.
One of the best ones.
Yeah. I still think the mushrooms is my favorite, to be honest with you.
I don't know. When you changed Jack's face from this facial expression to that facial expression to the next one, like that had me had my stomach in pain from laughing so hard. So.
Yeah, 8th Center, we don't mind if it's all complete woo, man. You should have seen, you probably seen a while back, Ben set me up in the woo. And we went definitely UFO hunting one Monday. So, yeah, it's all good. So, so funny, though. Anyway, yeah, I guess that's pretty much it, guys. I think that's where we stand on Hutchison, though, that it's all kind of going back to the same effects. And it's just the amount of energy he's using and how he crosses the fields. But we know kind of the fields that are present. Like I said, if you're going to replicate it and you don't want to use as much energy he did, find a big steel box and start there.
All right. I'm gonna be really awful, and I'm gonna open it back up just slightly because I think it's worth mentioning. You know, the flip side of the coin of what Hutchinson was showing with the dematerialization effects, okay, is pretty much what Bernie is showing on his channel continuously with his transmutation and precipitating different elements out. So it's that is the flip side of the coin. Just to throw it out there, and I think that that's worthy of a whole conversation in itself. Is that flip side of the coin because it's all relevant, But we could leave that a tale for another day.
I think what he's doing is close to Bendini's work on when he's transmutating stuff. You know what I mean? I see real similarities there as well.
For sure. Throw the name. Bernie's in the chat. So, he's doing it too. And Bernie, I see it as on the other side of the coin of that.
Yeah. Bernie did 4 interviews with Hutchison and says, check out his channel, by the way. So, just a heads up for everybody.
Yep. And just know that I know.
Oh, okay. Gotcha. he wanted to talk transmutation with John, and I guess John's wife said no.
Yeah, I have a hunch that whatever conversation that John was privy to back in the day, she was too. And she probably has to keep him in line because he'll tell you anything, I would assume. You ask the right questions, you'll get the right answers. And the only thing keeping them alive is her probably, shutting him up.
And that makes sense.
Remember what the guy in the black suit told us?
Yeah.
This is what it is.
Well, I can already tell you how they did the plant mutation. That one I know very easily. So, yeah. Anyway,
trail of breadcrumbs that you can follow.
Well, there is, but don't just look at his anti-gravity effects. Look at his crystal cell. You know what I mean? Look at the fact that he's transmutating plants. There's certain things out there that you can look up that will have no problem. You know what I mean? Finding out some of these things.
Mm-hmm.
Let's see. Bernie says all 4 original Hutchison interviews are public on my channel. Only the 5th one where I was sabotaged. Gotcha.
Yeah, these things happen. Comes with the turf, I suppose.
I guess. I mean, one of those interviews, I don't know that I'd want to do live. It would be something I would want to do recorded. You know what I mean?
That's fair.
There's some things that lead somewhere, and there's some things that lead nowhere, and you know what I mean? You got to figure them all out. And I don't think you're going to get any direct answers, by the way. So, but it's always fun to do it.
Yeah. Well, as much as we try not to say the quiet parts out loud, sometimes it happens anyway. What are you going to do?
Oh, dude, as long as it's my secret, I'll tell you. But if it's somebody else's, good luck. I'll never tell you. You never get it out of me.
Well, that's exactly it. It's the same reason why, you like, I'm good friends with you and I've never sent you 8 sinners, things. Like if you tell me something in confidence, that's it. That's where it ends. So
that's right. So all right, man. I think we're pretty much at the end. Ben, what you got going on? You got anything coming up for Wednesday or?
Not for Wednesday. Maybe tonight I might do some streaming, making some circuits. So we might do some soldering, some lumen lamp or lightning thief devices, making those tonight if I have the energy.
Nice.
Very cool.
Joe, what are you up to, man? You got anything going on, or you just hanging out with the dog? And
Yeah, no, I'm hanging out with the dog, and I'd microwave myself some dinner, except I don't have a microwave, so I'll probably have to figure something out. Crack open the fridge and see what I can put together real quick.
no white people tacos this time?
No white people tacos today. I don't even like white people tacos that much. I know that's probably sacrilege, but like I'm kind of more of like an Al Pastor dude myself,
Gotcha.
Yep.
Man, microwave stuff, man. Oh,
what about you, Nathan? You got anything coming up?
So on Wednesday we have the builder's workshop, and I should be done with all of my prints by then. So we're going to do assembly on that, and put in everything, show everything, put it all in there, show each one rotating. I'm going to call up Joe, and we're going to look at it, and maybe we'll find some interesting stuff right away. But he wanted to see it spin for the first time, so
oh yeah,
I'm hoping, crossing my fingers, by Wednesday we can get that done. I'm going to try to build out the frame for it and everything else. But yeah,
I know. I am excited, and I know a lot of the people I talked to about this are really excited to see that thing start spinning. We're all wondering what's going to happen. We all got our bets placed.
I don't have my bet placed, just for various reasons. Like I need to see things first.
Yeah, I think honestly, I don't think much of anything is going to happen right away. To be honest with you, I think it's not till we get the hang of what's going on first, and then we start adding in the interesting elements like the aluminum, and then we start adding in the bismuth. Then it'll start to really make some headway. If we simply added some statics and some aluminum tape to it, oh man, I'm telling you right now, there's going to be some fun adventures in that.
Mm-hmm. I agree. I'm just still like wanting to see, like, before like even the phenomenal aspects of it are concerned. I'm just more interested in making sure that the mechanical aspects are all holding up. And it has nothing to do, because I think the design is perfect. I just don't know what the forces at work in conjunction with the mechanical aspects of it are going to ultimately result in. And I'm hoping that it's just simply a non-issue, to the point where then all I'm looking for is phenomenal results. Right.
It could be as simple as, I don't know, spacers in between it. It could be as simple as instead of little pins to hold it all the way around, it could be as simple as driving a hole right through it and pin it once so it stays no matter what. And either one's an option for me, man. I'm not ruling it out. And then I'm going to sink any nut that's in there with a lock nut into the plastic. So, you got little threaders that'll go in there, and then we'll have, locking washers, or if I have to put a bolt in there, it'll have a lock nut, and I'll just melt it right into the plastic. Just anything we have to do to make it work right so things aren't flying out at me, I'll be happy with that.
Mm-hmm.
So,
do you have any idea what RPM you're aiming for, provided that it's all, keep them together and whatnot?
We'll try the initial about 1,000 RPM, and then I think in general running of it, probably about 2,000 to 4,000 RPM is not out of the question.
Okay.
I don't think I want to get it up to 7,000 RPM. There's probably no reason to push that thing across where it blows out my computer.
You don't want to run it at 35 where the Dremel goes?
It could. I know you're all on the Dremel, but I can tell you right now, when this thing starts resonating, you'll know it.
Uh-huh. Yeah, that's true. It's structure itself, and just, whatever the permanent magnets are bringing to the table is going to have a preferred frequency band regardless.
Mm-hmm.
So whatever that is, I guess that's to be determined.
Well, that's kind of the whole point of it, right? It could be that we build the thing and then put a bunch of stuff into it, and then we have to S-can the whole thing and start over.
Yeah, and you know what? That comes with the turf, doesn't it?
Yeah. I'll tell you what, though, I'm going to get every ounce of it that it has before it shreds itself. That's for sure.
Yeah, for sure.
Yeah, and I don't think when we add in the aluminum and stuff, depending on how much distance that puts out from each one of those spheres, it may change the frequency of it enough where I have to change the distance in something in order to compensate for them. You know what I mean?
Yeah. Well, like any other system too, its stability is going to be exaggerated with higher RPMs. So, things will become more apparent the faster you spin it. So, just take it slow.
Yeah. Yeah. All right, man. So, yeah, that's about what's going on, guys. That's what we're looking up to. And, like I said, we're going to add that Thursday show in. And once I get done with grandpa duties on Tuesday, I may add one more. Kind of just keep the vibe going throughout the week. So we'll kind of play that one by ear, but I definitely want to have people with their inventions on Thursday. So hit me up, even if it's in the woo. Let's do it. Let's find out. I mean, I met Joe in the woo on his rock, so it works out, man. Anyway, guys, I want to thank everybody for coming on and hanging out with us and talking about this. I really do appreciate everybody in the chat. You guys are awesome. It's been really cool tonight. Thank you, Joe. Thank you, Ben.
Yep. Peace and love, everybody. Have a good one.
Have a good day, guys.
Night.